There we are. And we'll give just a moment to get everybody in the room, okay? Please do me a favor and close the tab to the other room. Just because if you leave it open, you're going to hear both rooms and you're going to have some feedback, okay? So without further ado, here is Mr. Azasi.
Hello. Hi, students. Let me share my screen with you because I'm going to show you guys a PowerPoint. Okay, so like the same thing as last week, I'll be sharing my screen again, and so I can show you a PowerPoint. Okay, let's see. Okay, today's lesson is going to be over, I believe it's chapter 5, which is a finance math. Okay, I'm gonna cover like every section, not like in detail, but like a little bit of each section. That way, when you actually see this, see the sections with your instructor, you more or less you'll be able to know what's going on. Okay, so let me start the slideshow. Okay, now today's topics covered are going to be simple interest, which is I believe section 5.1. And then compound interest, which is section 5.2. And then future value of annuities, which is section 5.3. And present value of annuities, which is section 5.4. And here, guys, I have a picture of a calculator. Why? Because we're going to need one. Okay, and I'm going to show you how to use the TI-83, TI-84 to solve some of those problems, right? Because they're going to give you some formulas. And at times, there's where the students make the mistakes because they don't know how to plug it into the calculator. Okay, so I'm going to show you step by step how to do that. Okay, so let's begin. Simple interest. What's simple interest? Hey guys, the interest, here I put INT for interest, but I believe in the book it only has an I. But I don't want to use the I only because it looks like a 1. Okay, that's why I put INT for interest. Hey guys, interest is, for example, let me show you an example of what it is. Say, for example, that you guys ask me, hey, Mr. Isasi, can I borrow some money from you? And I'll say, yes. How much do you need, right? So they say that you need $1,000. So I said, okay, guys, but you know what? I'm going to charge you some interest, okay? Because I want to make some money. I don't want to just lend my money out. I want to make some money. That's the way the banks operate, guys. Okay, so the interest is the money that you're going to pay me plus the money that you owe me, okay? So there's like 2 different formulas that I'm going to show you right now. This is the first one, okay? So every time that you're going to solve a problem, guys, you're going to put every variable, vertically. For example, the INT stands for the interest. The PV stands for present value. You see right here. The interest is a fee paid to use someone else's money. And the PV is a present value or the principal. The R is going to be the interest rate. And what's noticeable about the interest rate, it always has a percent symbol. Okay, and the time is going to be in years. Okay, in years. Now, this is one formula that you can use, and here's another one. Okay, for example, this formula here, guys, is a future value formula. So, for example, say that you borrow some money from me, right? So you borrow the amount, and then plus you're going to pay me some interest, right? So, for example, if the interest was say $100, and then you borrow like 1,000 from me, right? So you add them up. Okay, but from this formula here, if the future value equals to present value plus INT, which is the interest, we're going to get another formula from here. How are we going to do that? Is that we're going to plug in this and the PV RT into the INT here. Okay, you see here's my interest. Now here, we're going to factor out the present value, right? Because these two have in common the PV, which is a present value. So I'm going to factor it out. So what's left? 1 plus R times T, because PV times 1 is PV, which is a present value, and PV times RT is PVRT. So that's where this other formula comes in. So in reality, guys, this formula is the same thing as this one, plus the present value. So here we're going to have this formula like one formula, and here's the other one. Okay, and for this one, again, every time that you're going to solve a problem, you put all the variables, and then you're going to be plugging in what they give you. Here, the future value, which is the FE, is the sum of the principal and the interest earned. You see, the sum of the principal plus the interest earned. And the present value is the present value of principal, the PV, and the R is the same as the one over here, and so is the T, time in years. Okay, now, let's do an example here. Okay, before I forget, you need to know this, guys, okay? Please don't forget this, need to know. Hey guys, every time that I tell you something extra is things that I found out that students make mistakes on. Okay, so I will always bring it to your attention. I'm here in this PowerPoint, and also I do that in my classes. I always tell students, you know what? This is where some of the students make mistakes. So please be careful, because that way you will make the same mistake. So if months are given, right? Say for example, they don't give you the time in years; they give you like 3 months. So what you're going to do, you're going to put the given months over 12. That'll be the time. Okay? So given months over 12, it is 19 years. And also, the interest rate must be in decimal. So you're going to take away the symbol and move the decimal place 2 places to the left. So 5% is equal to 0.05. This is crucial. Here's where a lot of students make mistakes. And also here with the time, when the months are given instead of the years. Okay? Now, let's do an example here. Okay, let's see here. Say Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle and how much interest did she pay. So in other words, Martha's going to pay the $12,000 back, right, plus the interest. So which formula should we use? Does it matter? Is it that one, right, for the interest, or is it the other one? Does it matter? Because in this case, it does not matter. No. I'm going to show you how to use both formulas, okay? Because at times the students get all kind of scared, because most students are scared of word problems, and they say, well, what should I use? Okay, but it's very, very simple, guys. Here's the key thing, guys. You see here it says simple interest, right there, simple interest. It means you can use the simple interest formulas, which is this one or this one. So simple interest means you're going to be using one of these formulas. So let me show you first with this formula over here, okay, which is this one, the INT equals to PV times R times T. If you use this formula, right, then you have to use another one. Because remember, they want to find out how much money did Martha pay to her uncle, everything together, plus the interest. So if you use this formula, you have to use this one too, okay? So again, you put all the variables down, and then you're going to extract the information. So for example, what are we looking for? We're looking for the interest, right? Because find the total amount and the interest and how much interest. So for this formula, you're going to find the interest first. And then you use this one to find the future value. So again, what was the principal or the present value? Was 12,000. Hey guys, what's my interest rate? Anybody? Anybody want to put it into the chat? The interest rate? If you want, give it to me as a decimal. Did somebody
Yes, Giselle said 0.035%.
Giselle, but yeah, it's correct. Okay, but one thing is that you don't put the symbol no more. Okay, it's just 0.035, because when you go from percent to a decimal, you're going to go to the left 2 places, right? So you're going to go like this, 1, 2, and you put that decimal point and you take away the symbol. Okay, but it's going to be 0.035. So in a way, Giselle, you were correct. Okay. Okay, now, and the time is going to be 5 years. So what do we do, guys? We plug into the formula everything. Hey students, they're always going to give you everything except for one unknown. So your job is to extract the info from the word problem and then just solve for the unknown. So here, guys, just put it in your calculator. You're going to put 12,000 times 0.035 times 5, which gives us $2,100. So this is the interest, guys. So if you use this formula first, you're going to find out how much Martha paid in interest. So then to find how much he paid total is going to be the present value plus the interest. So if you add them up, it's going to be 14,100. So that's how much Martha is going to pay back to her uncle. Okay, which was the 12,000 that she initially borrowed plus the 2,100, which was an interest. So total Martha paid was 14,100. Interest paid was 2,100. Okay. Okay, now let me use this formula now on the next slide. Okay. So again, same word problem, but now let's use this one. Okay, now again, if we use this one, guys, right? So we're gonna put everything that's there. There's my FV, my PV, my R, and my T. So we begin to put in the information that's given. So the present value is 12,000 again. This rate is 3.5%, which is 0.035, and the time is 5 years. So let's plug everything in. My future value is, right, my present value. And then there's my interest rate, and there's my time. So all we do is put in the calculator just the way it is. And we get, right here, we get the future value. So if we get the future value, guys, then we have to use this other formula then, right? Because the interest paid is the future value minus the present value, which was 14,100 minus the money that Martha borrowed. And that's my interest. So does it matter which formula you use? Most of the time, guys, for the simple interest, it doesn't matter. Okay? You can use either or. Unless, like, example number 2. Check example number 2. Okay, Mariana will need to pay a tuition bill of, any questions, guys? Are you guys okay? Okay, I'm going to continue then. Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough money to pay the tuition? So check this out, guys. So here, they don't even ask for the interest, how much interest, right? They don't even ask that. Okay? But one thing that we do know is going to be a simple interest problem, right? Simple interest right there. So we're going to use that formula right there. Okay? So we put everything down. Okay, now. Okay, guys. So what are we looking here? Is this 7,000? Is this money amount here, the 7,500? Is it the future value or the present value? Okay, what are we looking for? Check this out. What dollar amount can she deposit today, right? This right here today, guys, means the present value. So we're looking for PV. Okay? So, hey, guys, please, guys, when you read these problems, do not get nervous. Just read them correctly and also begin to extract the info. Okay? Because this is very simple, right? The interest rate is going to be the one with the percent symbol. And the time is going to be in months or in years. So these two are kind of basic. Right? Are kind of basic. So this is your future value, right? Because that's how much money she wants in 10 months. She wants to pay the tuition bill in 10 months. So then we put everything that we extracted from the word problem. So this will become, right? So we move it 2 places to the left, and we take away the symbol. So this is my interest rate, 0.0125. And again, remember, guys, the 10 months is going to be in years, so you put 10 over 12. And again, you don't have to simplify this if you don't want to. Don't. Also, guys, if you put it in the calculator, what would it give you? 5 over 12. Because most of the times, if you put 10 divided by 12, it's going to give you 0.833333. It never ends. So when it never ends, guys, do not round out, because most of the problems that are on your My Math Lab, you have to round them up to the nearest penny. So if you run off too early, guess what's going to happen? You're going to get it wrong because the My Math Lab is real sensitive. It wants it to the nearest cent. So don't run that one to the very end. Okay? So then, how do we plug it in? Here we go. Right? we can use this formula or this one also, guys, but I don't like to use, my personal, for personal reasons, I don't like to use this one. Why? Because I don't want the student to have too many formulas. Instead, I'm gonna show you how to use this one here, and then I'm gonna show you, how to put in the calculator step by step with an easy flow. Okay. So if you use this one, okay, I'm gonna show you because this one, that's the way the book does it, but then I'm gonna show you this one over here. So all right, so you just put the future value, 1 plus 0.0125 times 10 over 12, which is equal to, we do the bottom part first, which gives us 1.01041667. And this is my answer here, guys. So it's going to be 7,422 and 68 cents, right? Because we round off. Okay, now let me show you with this one here. Again, this is the way that my math lab shows you, because if you ask for an example of my method, right, help me solve this, it's going to show you this way. Okay, but this formula is easy to use. Okay, another way without clearing the calculator. Here's with a T83 or T84. So check this out, guys. Here's what you do. Right, the formula right there. So plug everything in. So what I'm going to plug in the calculator, guys, is this right here. You're going to put parentheses 1 plus 0.0125 times 10 over 12, close parentheses. You see, you're going to put it just the way it is in the calculator. And that's the answer that gives you. But when it gives you the answer, guys, this is what you do. You hit, this is a key, it's called the inverse key on your calculator. So if you hit this key and then hit the 7,500, it means like if it divides it by this right here, that's what that means. The inverse key. When you press on the inverse key, you should see answer to a -1. Then you enter 7,500 and it gives you the result. Okay. Okay, now, if you guys have a calculator right now with you guys, please try it. And if not, when you get access to this PowerPoint, right, follow my notes in green right here. Follow all this right here, because this is going to help you to solve it with a steady flow without stopping the calculator or without clearing it. And I'm going to show you more examples later on today. Okay, but most of the times, guys, the main concern for the students is how to plug it into the calculator, because students don't know how to plug it in. Some students don't. So during a lecture class, what I do, guys, on the exams, I tell my students to set everything up, and if I only have 10 problems, right, each one is worth 10 points. If you have everything right, the setup and everything, for example, if you have everything like this, right? Say, for example, this one here, you have it like this, and the answer is completely off. I'll give you 8 points credit because you knew how to extract the information. The only issue was that you didn't know how to plug it into the calculator. So that's why, guys, here in green, all this part here, also in the green, it will show you how to put into the calculator, so you will make that mistake. Okay. And then you and then you enter, and then that's the answer. So again, when you press on the inverse key, after you get this right here, right? After you get this, the 1.010416667, you press the inverse key, which is this key here, and then you're going to see this in your calculator, the answer to a -1, and then you enter 7,500, then you enter it again, and you get the answer. Okay. Okay, now, again, simple interest. John received $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was 125? So check this out, guys. So which formula are we going to use here? They give us the present value, right? This is how much John received, which was the present value. This was the interest rate charge. And this was the interest, the INT. And this, we're looking for time. So here, guys, we have to use, all right, so which one do we use? We have to use this one here. Because again, this is the present value that was given or that was loaned. This, the accrued interest, was my INT. This is my interest rate, which is my R. So we're looking for T. Okay. So which one do we use? We're going to use this one here. What is given and what are we looking for? So what are we looking for? We're looking for the time, right? How long was the term for? So how long means time. So then we began to extract the info, right? That was my present value. That was my interest rate, right? But we wanted in decimal. So you move it 2 places to the left and you take away the symbol. And that was my interest. So formula, plug everything in. So here, guys, first we're going to multiply these right here, right? And then divide by whatever we get. So this is 250 because of 10,000 times 0.025 will give me 250t. We're going to divide both sides by 250. So it's going to give us 0.5. So it'll be 0.5 years or half a year. That's your answer, guys. Okay. And at times, in some of your problems, they might also want you to find the interest rate. Okay, you do the same thing. That's what we did here. Okay. Now comes, this is compound interest. Okay, compound interest is for section 5.2. For compound interest, there's a different formula for that one. Okay, this is the formula. It's either this one or this one is condensed because the R over M is equal to my I. And the M times T is equal to my N. I prefer for you guys to use this one here because it's less hassle in the calculator. Okay, and I'm going to show you right now how to use it. Okay. So here's what every term is. This is the future value, the future or maturity value. The PV is a principal or present value. The R is the interest rate per period convert to decimal, right? Convert to decimal and you take away the symbol. M means the number of compounding periods per year. So this is the only thing that's new here, right? And then the I is also new and also the N because the T, right? The time is in years, but the I is equal to R divided by M. You see, this here, guys, is my I. R divided by M is my I. And my N is equal to M times T, which is the total number of compound periods. Okay, now. So here are the key words for compound, because this is where a lot of students make the mistake. They don't know what the M is, right? Because they'll be saying different words in the word problem, so it means different compounding. For example, compound, these are the key words for compound, and this is the value for M. If it says yearly or annually, M is equal to 1. If it says bi-yearly or semi-annually, M is equal to 2. It means twice a year. If it says quarterly, M is equal to 4. Monthly, M is equal to 12. Weekly, M is equal to 52 because there's 52 weeks in a year. Daily. Hey guys, for daily, most of the times it's 365. But at times the book wants you to use 360. Okay, so if the book doesn't tell you to use 360, you use 365. Okay? And again, if the book tells you to use 360 and the problem says to use 360 for daily, then you use 360. If not, use 365. Now, how about continuous? Continuous, guys, is a totally different formula. The formula changes. Okay? Okay, now let's move on then. Now let's do an example here, guys. Let's do actual, okay, now. Compound interest can be used to invest a certain amount of money without depositing additional money. Okay, let me show you an example of what this means before we get to the example. Okay, guys, let's pretend that that you have, say, $10,000 right there at your disposal right now. That your grandma gave you a check for $10,000. What are you gonna do with it? You can just keep it, right? Or cash it and have it at your house, or put it into the bank and invest it, make interest out of it. That's what it means here. So compound interest can be used to invest a certain amount of money without depositing additional money, which means you're not going to put more money in there. That's another section in 5.3. I'm going to show you when you're going to deposit an amount every month. Okay, that's for the 5.3 and 5.4. But for this section, is only no additional payments or money is put into the account. Just whatever you're going to put in at the beginning. Okay, and here's an example. For example, say you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much will be in your account after 5 years? And how much interest did you earn? Okay, so here's how we solve this problem here. First of all, right, we have to get this formula. And I said, which remember guys, I don't like to use this formula. I like to use this one instead. Okay? Okay, now, so again, I'm going to put every variable. Oh, okay, let's see here. Okay, easier to import in the calculator, so that's why I want this one easier. That's why I said I prefer to use this one here. Now, I'm going to put every variable that's here. My FV, my PV, my R, my M, and my T. And then my I, right, my I, which is here, is equal to R divided by M. And my N is equal to M times T. Hey guys, it's easier to do it this way because once you get this right here, the R divided by M, and you plug it in here, and that's it. The only time that I tell you do not put the I if it gives you a decimal that never ends. For example, if it gives you something like 0.3333333, don't do that. Leave it as a fraction. Okay, because again, you want to get because it's going to tell you to round off to your nearest penny, to your nearest cent, which is 2 decimal places. So if you round off here, you're going to get the wrong answer at the end. You don't round off to the very end. Okay, so here, what are we looking for, right? We're looking for the future value because it's in here how much money will be in your account, right, in 5 years. So right away, we know the future value. So now, the money that's there, guys, has to be your present value, 1,000. What's my interest rate? 6%. Okay, now, hey guys, anybody, how do I put 6% as a decimal? Please put it in the chat. Anybody?
Yep, Giselle said it's 0.06.
Very good, very good.
Giselle.
Okay, guys, what's my M? How many times is it compounded? What does it say right there? Compounded, what would it be?
They say 4.
Very good, 4. The time, right? The time is obvious, right? It's 5 years. Now here, guys, we're going to put R divided by M. So what's R divided by M? 0.06 divided by 4. Now here, guys, we're going to use a calculator. Okay, and again, if it gives me like a long decimal, we don't use the I. We use this for the I. Okay, this is what it gives us. Gives us something nice and sweet, 0.015. So this is my I. And then what's my N times T? My M is 4, my T is 5. So 4 times 5 is equal to 20. Now, we plug everything in, right? So there's my PV is 1,000. My I is 0.015. And my N is 20. You see, guys, compare this to this one over here. This is very simple to put in the calculator because how do we do it? Just straightforward. Put that in the calculator, guys, just the way it is, and this is your answer. But remember, you always want you to round down to the nearest penny. So this is a 5, right? This is more than 5, or 5 or more. You add 1 there, which will be 0.86. So after 5 years, there will be $1,346.86. Okay, now.
We have a question, Mr. Azasi. So
Yes.
they ask, so if I is a periodic number, we just leave it as a fraction?
You leave it as a fraction. No, you leave it as a fraction when it gives you something ugly.
That's
let me give you something ugly. Say, for example, if it's say 0.035, say divided by 12, 0.035 divided by 12. You see, it gives me something real ugly. If you guys have a calculator, put 0.035 divided by 12. Say it was 3.5% compounded monthly. Then it'll be 0.035 divided by 12, right? So you put that in the calculator, it's going to give you something like 0.00291666667. You see, guys, that's too long to put there. Does that make sense?
What should they do in this situation for the calculator? Should they put it in parentheses?
Yeah, no, here you don't have to because it follows PEMDAS. But if you want, it's always wise to put every fraction in parentheses to eliminate mistakes. But in this case, you don't have to because it will follow PEMDAS. The calculator, okay? But to play it safe, yes, put it in parentheses then, to play it safe, okay? Are you guys okay up to this point? Can I move on?
Yes, sir.
Okay. Okay, now guys, so we found, right, the future value, how much money will you get in the 5 years? So then you got your money back, right? Because it was 1,000, right, that you put in there, so you got a little bit of money extra, right? So how much interest did you earn? The interest earned will be the future value minus the present value. So this is my future value, what you got in 5 years. And the present value was 1,000 that you invested. So it'll be 1346, $1,346.86 minus the 1,000, which was, that's how much money you got extra. Okay. So you earned $346.86. Hey, so let me share something with you real quick. Every time that I teach this class, 1324, my objective as an instructor is to always try to connect with the students. And the first week is when I try to connect. And most of the times I do. But eventually, guys, some students, they don't seem to want to connect, right? I mean, by that I mean, connect is that I give you the confidence that you guys can ask me anything in regards to math, and I'll help you, and I will always answer your questions, right? So you guys can feel comfortable with the way I do things. Now, for the students that don't connect, in chapter 5 is when we begin to connect. Why? Because why are you guys in school for? Isn't it to make money? To make money, right? That's what you're in school for, to get a degree and make money. And we get real personal, right, with our money. So here, guys, is when I show you how to do stuff like, for example, how to buy a house, how to buy a car, and for the banks, for them not to rip you off and stuff like that. So here's where we begin to connect, to reconnect with the students that didn't connect with me back at the beginning. Here's where because we all want money, right? And we want to know how to use our money wisely. So here, guys, and I know when I get to the next section, which is 5.3, is going to be very, very interesting. Okay, guys, that's when it gets kind of real intense and real nice, because you're going to learn a lot of information. Okay, now, continuous compound interest. Remember, guys, continuous? Well, let's get the same problem as before. The one that we just did. Okay, the one over here, let me show you. Oh, no, but let me go next. The one that we just did, guys, wasn't it the same thing, except this was compounded quarterly? What happens when it's continuously? Well, let's find out, right? This means it's going to be a different formula. So we put everything that's there. The E, guys, is a base, right? And that's in your calculator. The E, I mean, a lot of students don't know where it's at. It's going to be on, if you have a TI 8384 calculator, it's going to be on the first row, on the first column. It's going to be 1, 2, 3, 4, 5, 6. It's going to be like the second key, but it's going to be like in blue or in yellow. Okay? So I can show you where it's at. Anyway, guys, so again here, right, we're looking for the future value. So here, this is my present value is 1,000. There's my interest rate, which is 0.06, and there's my time. Continue. Hey, guys, I think I heard, does anybody have a question?
Yes, sir. They asked, what does it mean that it's continuously?
Continuously means that it's compounded without stopping, discontinuous. For example, if it's quarterly, it means it's compounded every 3 months, right? Because there's 4 means that it's 4 times per year. Everything is per year. So, for example, if it's compounded twice, it means that it's compounded 2 times a year. Continuously, it means that it keeps, it keeps being compounded without stopping continuously. Okay, and here, guys, is we're gonna know the difference. Okay, we're gonna see the value that we got, that we get here, and the value that we got on the last one. Okay, now, so there's my formula. So plug into the calculator. You're gonna put 1,000, then you're gonna go to the base E and then put 0.06 times 5. Again, here, guys, be careful with 0.06 times 5. To be safe, input in parentheses, because a lot of students, they just put 0.06 times 5, and then but it follows PEMDAS. So what it does, it multiplies all this, the 1,000 e to the 0.6, and then multiplies everything by 5. That's why they get it wrong. So be careful with that. And it depends on the type of calculator that you use. Okay, so be careful with that right there. So my future value will be 1,349.86. So if you notice, guys, this amount of money, I think it was $3 more, right? Because the other one was 1,346, correct? Something like that. I believe it was. So check this out, guys. So when you're going to borrow money from a bank, okay, when you're going to borrow money, if you notice, the more time that it's compounded, the more money you get. For example, right now it was compounded quarterly, right? So it was 4 times a year. Now this is continuous. Even though it's $3, guys, it can add up. Okay? So when you're gonna borrow money, they're gonna compound it continuously because they want to get more money from you. But when you're gonna when you're gonna put like an account or something, right? They're gonna offer you compounded less because they don't want to give you that much money back. I mean in interest. Okay? So again, the more time that is compounded, the more money you get. So how much interest did you earn? And again, same as before, which is the same formula, and it will be 349 and 86 cents. And again, on the one compounded quarterly, we got 346, which was less. So the more it's compounded, the more money you're gonna get, or the more money you're gonna pay, either or. Okay. So can I move on? Are you guys okay with this? Okay, let me move on then.
Yes, everyone says yes.
Okay, now, okay, check this out. I want to be earning, here's like an actual example here. Okay, let's pretend that I want to retire in 15 years from now. Okay, and I want to be getting 100,000. I want to be earning an annual salary of 100,000. Okay, so I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? Okay, so we're going to use the compound interest formula. And again, this is easier to use, okay? So let's begin by, again, easier to put in the calculator. So let's begin by plugging everything in. So what are we looking for? What do you guys think? This money, when do I want this money? Now or in the future?
They say future.
Oh, you're correct. That's why we're looking for the present value. How much money do we need to put in right now, right? So that's why this is the future money, and this is what we're looking for. And again, guys, everything is very obvious after you know what formula it is. Everything is very obvious, right? Because the 15 is the T, the 4% is the interest rate, right? And annual means that it's gonna be compounded once a year. Okay, even though it doesn't say that, it's gonna be annual. Okay, here we go. So that's 100,000 that I want in 15 years. There's my 4%, right? We convert it to a decimal. The M is 1 because it's annually. The time is 15 years. So let's get the I, which is the R divided by M, which is 0.04. And the N is equal to M times T, which is 1 times 15. Plug everything to the formula. Okay, now, here, guys, is what I'm going to show you how to put it in the calculator. Okay? Because if you put this, guys, right, first you start with this right here. And you put it down, right? Then you can divide both sides by 1.80943,506 to both sides, right? And you get this right here. And then the present value is equal to $55,526.45. Okay, so that's how much I need to input. Okay, that's how much I need to put there per year. Okay, now, again, easy way to use in the TIA 384 calculator. So I'm going to put this over here, right? So that goes there. Here's how you start. You're going to input just the way it is. Hey guys, if you have a calculator, please use it right now. You're going to put parentheses. Let me do it. 1 plus 0.04, close parentheses, to the power of 15. You can enter. You should get something like 1.80943,506. That's why you should see it right in the calculator. Now, you're going to press the inverse key, which is that one there. You press the inverse key, and then you enter. You should see that in the calculator, and then you're going to enter the 100,000, and that's the answer. You see, guys, you get the same thing. And this way is without stopping the calculator at all. Because here, right, here you would have stopped it here, right, and put that in there, and then you clear it, and then you put 100,000 divided by this, guys. So here, it is straightforward without leaving the calculator. I mean, without stopping or clearing it. And from now on, guys, I'm going to show you this way, okay? This is a formula that they use in the book. But again, I don't like to use this formula because I like to tell the students, hey, guys, there's about 3 or 4 different formulas for the same thing, or like 2 different formulas. That's why I like to keep it like, I mean, with this one here. Okay? Okay, now, here's where it gets kind of nice here. Future value of an ordinary annuity. The ordinary annuity are payments at the end of every month, or at the end of every periodic timetable. Okay, so again, this formula is the same thing as this one here, because the R over M is equal to my I, and my N is equal to M times T, as you notice. So this formula is easier to plug into the calculator. Okay, and here it tells you what everything is. Okay, let me show you an example of what this is all about. Future value ordinary annuities can be used to accumulate funds for some time in the future. You must set regular deposits during that specific time. Examples, how do we use these? Okay, hey guys, with this example, I like to put it to connect with my students, and that's why I can put something like that actually is going to happen or can happen. Most of the examples in the book, right, they're also like real life scenarios, but when I came up with my own examples, it's easier because it's easier to relate to the student. Okay, for example, let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. So you want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? Okay, isn't that kind of interesting, guys? If you can afford to save $1,000 from your paycheck every month, and then maybe you can use it in 20 years. Say your kid's going to go to college and stuff like that, right? So you want that money in the future, and that $1,000 is something extra that doesn't hurt you to put it away. So I'm going to do an example like this one here right now. And example number 2, let's say you are planning on sending your just born child to college when he or she turns 18. Since college tuition is consistently on the rise, you want to make sure you have enough money in 18 years for your child to attend college. So I'm going to use like these examples here. Okay. So here we go. Example 7. You can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. An investment company offers 3% interest for 20 years, and you deposit $1,000 at the end of every month. How much money will you have in 20 years, and how much interest will you earn? Okay, let's find out. So we use that formula, so we put everything down, right? So we begin to extract the information. Hey guys, the future value, here we want the money right in the future, right? So we're gonna try to save money and put money in an account every periodic timetable, or every month or every quarter. I mean, it depends in when it's compounded, and then we're gonna get money in the future, okay, to reach some kind of goal. So we're looking for the future value, right? So the payments are $1,000. My interest rate is 3%. Converted to a decimal, compounded. What is compounded? At the end of every month, right? So M is equal to 12, right? It's every month. That time is 20 years. My I is R divided by M, which is 0.03 divided by 12. If we put that in the calculator, it's going to give us something nice, I believe. Yes, it does. It gives us 0.0025. And the N, which is the N times T, will give us 12 times 20, will give us 240. Well, now what do? We plug everything into the calculator, right? There it is. Plug everything in. Now, right, so here, guys, we start by doing this first, right, which is that right there. Then we divide by 0.025, and we get this right here. Then we multiply 328.301991 times 1,000, and it gives us, what is it, 328,301. And this runs off to what? To 302, correct? So this is how much money you're gonna have in 20 years. Isn't that like a lot of money, guys? Let's see how much money was actually interest. Okay, now how to use calculator without clearing or stopping. One steady flow until you reach your answer. Here we go. So we're gonna start by inputting this right here, the numerator, which is 1 plus 0.0025. Close parentheses to the power of 240 minus 1 in the calculator. So you should see that's right. That's your answer. that you get on the screen. And again, without leaving your screen, then you're going to press on the division key because you're going to be dividing it by 0.0025. So you should see answer, and then that's my division on the screen, and then you enter the 0.0025, which is this part here. Then you're going to put enter, right? And then you should see that. That's the answer for all this right here. You see it right there. So you should see 328.301.9981 on the screen, and then you press on the times key, right? On the times, because you're going to multiply it by 1,000, and then you should see that on your screen. So then you enter it, you put 1,000 enter, and there's your answer, guys. You see, same as here. So when you have a problem, guys, just do it the way, just follow this PowerPoint here, guys, or you can write these steps down. Okay? So it'll be $328,302. So how much money did you invest? So there were 240 payments, right? So 240 payments at 1,000 per payment. So you multiply these two, which was 240,000. So check this out, guys. So you end up paying 240,000 out of your pocket. So the rest was interest that you earned, or free money. How much interest did you earn? We subtracted, so you earned $88,302, guys. Isn't that amazing, guys? That you can afford to save $1,000 for every month for 20 years. Then at the end of 20 years, you got $328,302. Yeah. Okay. So that's how much the interest you made. Okay, now, guys, because it's almost time, let me go a little bit faster here, guys, because really I want to get to the next one where it's going to be 5.4, which is about buying a house. Okay. So now, you're planning on sending your just born child to college, right? When she turns 18, you want to have $250,000 in the account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? So in this case, guys, okay, so we're going to put everything down, right? So what are we looking for? You want to have, so we want to have that, right, in the future, right? So we're looking for the payments. How much should we pay every month? So again, let's plug everything in real quick because I want to get to the next section, which is about buying a house. Okay. So again, guys, so we plug everything to the formula. So here, guys, I'm going to do it the way I did in the calculator. So first, I'm going to put the 1 plus 0.0125 to the 72nd power minus 1 in the calculator. There it is. You should see 1.45920268 on your screen. You're going to press the division key, right? Because you can divide it by 0.0125, right? 0.0125, then you enter it. So you get this answer is all this right here, guys. All this operation here. So then, guys, right? Because we wanna divide or multiply by the inverse. We get this key means that I'm going to divide this by whatever the answer I got here. That's what the inverse key means. Or that I'm going to multiply by the reciprocal of both sides. Right, and then you enter 25,000 this, guys. So you multiply the inverse of this times 250,000, and that's my answer, guys. It gives me $22,161.25. So the payments will be $2,161.25 every month. Okay. No, this will be every quarter. My bad, every quarter because this is quarterly. Hey guys, are you guys okay up to this point? I know that I'm going a little bit fast, guys, because I want to get to the next section. Okay? Okay, now, so extra information. How much money did you put into the account? So there were 72 payments, right? So 72 times 2,161.25. So actually, you put 155,610. That's what you put in there. And the rest for the 250,000 was money that you got in interest. So that much money came out of your pocket. So how much interest did you earn? We subtract the future value minus what you got here, guys, right? But minus the total payments times the payments of the 72. So you got $94,390, almost $100,000 of interest of free money. Okay. So that came out from the interest. Okay, now present value of an annuity, ordinary annuity. So again, these are the formulas. I'm not going to be able to do one example, I think. Okay, guys, and that's it. Anyway, guys, this is the most common use of present value. Hey, guys, the present value is to purchase expensive stuff. Most of the times, to purchase something expensive like a car or like a house, right? You want the money right now because you want to go to the bank, right? You want to go to the bank and say, you know what, I need this much money now. Can I have the loan? That means you want the money now. That's why it means present value. You want the money now. Examples. You want to purchase a car. What are your monthly payments and how much will you end up paying? You want to get an idea on how to process, on the process of purchasing a house. So to purchase a house, guys, what do we need? Key factors of purchasing an expensive item and payments, right? Like a house. You must have a job, because no job, they will give you the loan. You must have very good credit. The better the credit, guys, the lower your interest rates. Okay, the higher your credit score, the lower the interest rate you will get, which is good because you'll be paying less in interest. And get pre-qualified for a maximum amount of the loan. So for example, say that you want to buy a new car, right? It's always good to get pre-qualified because you don't want to be looking for something really expensive that is out of your league. Okay? So say that you have a nice job, right? So just go to your bank and say, you know what, could you pre-qualify me for what's the maximum loan you can give me? And this way you can go and look at cars, right? Like real relaxed because you know you can afford, you know your limit. Okay? So now, so let me show you an example here. This is about buying a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? And how much interest did you pay? Okay, so again, this is the formula that we're going to be using. Okay. So we put everything down right. So we got the PV, the payment, the R, the M, the T, the I, and the N. So let's extract the information, right? We're looking for the payments. So the PV must be the 26,750. What's my interest rate? 4.2%, right? Converted to a decimal is 0.024. I should have put this more over here, guys, okay? I'll fix it. The N is 12, right? Because monthly payment, so that means your compounded is 12. The T will be 5 years, and the I will be 0.042 divided by 12, which will give us 0.0035. And the N is equal to M times T, which is 12 times 5, which will give us 60. Let's plug everything in. Okay. And again, now do it the way I did it in the calculator. So we start with, you input the 1 minus 1 plus 0.0035 to the negative 60. Right, so you should see that on your screen. And then you press on the division key. And again, guys, these steps here in the green, there's no way you can mess up because I went step by step for you seeing everything. So this way, all you do is put that in, how I'm showing you here, all this information. And then at the end, you're going to hit the inverse key, and you're going to hit the 26,750. You see, guys, it tells you what you're going to see every step. Right, then you press the inverse key. Then you press this amount, and you get that answer. So it's going to be $495.06. So that's how much are your payments per month. So can you afford a car like that? I don't know, right? It depends on you, how much money you make a month. So then, how much money did you end up paying for the car? It wasn't really that much. That was how much the car was worth, right? So the loan was for that much, but you can end up paying because the bank never loses money. So they want to make money. They want to make money out of you. So how much money did they make out of you? There were 60 payments, right? At $495.06 per payment. So we multiply those out. So that's what I get. So we get $29,703.60. So that's how much you end up paying for the car, including the interest. So then how much interest did you pay the bank? The PMT stands for payment. The PMT stands for payments. Is that your question? Yes. Okay, so now we subtract, right, the total minus what we borrowed. So this is how much you paid in interest, which was almost $3,000. Okay. Okay, now guys, let me show you this more example real quick. This is when you buy a house. You want to purchase a $325,000 house with a 36-year fixed rate at 3.9% interest. What are your monthly payments and how much interest that you end up paying. So that's my formula, right? We put everything down. So let's see. What are we looking for? We're looking for the payments, correct? How much was the present value? This is the amount that you're going to borrow right now. So that's how much was the loan for. The R is 3.9%, right? We convert it to a decimal. The M is 12, right? Because it's monthly, they're monthly payments. The time will be what? 30 years. The I will be 0.039 divided by 12, right? We put it into the calculator, we get 0.00325. The N is going to be M times T, which is 360. So again, we plug everything in. And again, we're going to do it like before, right? Because at times, guys, students will tend to mess up when they try to put everything like that in the calculator, which it can be done, but you have to be real careful with the parentheses. That's why I tell my students to just follow my method here, right? So you're going to put the numerator here into the calculator. There it is. Then you're going to get the answer. So the answer from 1 minus 1 plus 0.0325 to the negative 360 will give us 0.689, and you see the rest, right? Then I'm going to hit the division key because I'm going to divide that by 0.0325. There it is, right? So we enter it and we get 212.0134431. So here, guys, this will be the same thing as the payment times this right here, guys, right? So we're going to hit the inverse key because we want to divide or multiply by the reciprocal of this right here on both sides. And that's what the key does for you. This key is real nice to use in problems like this one here, guys. So these are your payments. $1,532.92. So these are my monthly payments. Can you afford those payments? Right? Well, it depends on the job that you have. So now, how much money did you end up paying? Hey guys, this is gonna shock you guys, okay? Because 360 payments at $1,532.92, it's gonna be over $500,000, guys. So you're gonna end up paying $551,851.20, guys. Okay? Again, $551,851.20. So you paid that, right? So that was the total that you paid for the house. How much was in interest? Right? So you subtract this, you pay almost $250,000 in interest, guys. Hey guys, let me show you. Let me share something with you guys. How you can avoid paying that much interest. Okay, before we leave, because it's time to go. Hey guys, when my wife bought this house, the house that we live on, that was right before we got married. So she bought it, and she bought it under a 30-year loan, right? Like a fixed rate for 30 years. And I use these type of formulas, guys, to actually pay the house out. It's already paid off. I paid it off in 10 years. So instead of 30, I paid it off in 10. How do I do that? I began paying money straight to the principal. Because believe it or not, guys, the first 2 payments that you make at your house, most of the money goes to the bank as interest. The money wants to get your money first. I mean, the bank wants to get their money first. And then if you default, right, they won't lose that much money. If you end up claiming bankruptcy or losing your house, they don't want to lose that much money. So that's why they collect their interest first. But what I started to do is paying extra money. So every time that I do dirt on the side or that I did something on the side, I would pay it straight to the principal. But you have to tell the bank that this payment goes straight to the principal. Because if you just put it with your payment, most of the times they're gonna charge you interest on that too, because they're there to make money. The banks are. So if you put like a note or make an extra payment and say I want this to go straight to the interest. And guys, and I paid the house in 10 years. So you can use math to actually for your finances, guys. It's all about math. And a good example is when you buy a house. Okay. Hey guys, any questions?
Does anyone have any questions for Mr. Azasi before he has to leave? No questions? Okay. No questions, Mr. Azasi. I know you have another engagement right after this one.
Yes, I do. Hey guys, well, I want to thank you for everything, guys. And again, if you want this PowerPoint, Send me an email and I can send it to you. Okay, again, let me put here my email here in the chat, and you guys can email me and I'll send you the PowerPoint.
Thank you, Mr. Azasi.
Oh, you're welcome.
Um,
Because also show you guys a weekend of fast at the end, because I wanted to cover that up at the house, because most of the times that's when that's what catches the students' attention, is when buying a house, buying a car. Okay, but I believe the PowerPoint is very informative. Just follow the steps. Just follow the slides, and you should be okay. Okay.
Thank you, Mr. Azasi. Make sure you guys look in the chat. There's a link to sign in today. Make sure you do that. And if you could take a moment to fill out the survey, we'd greatly appreciate it. We'd also like to invite you to next week's TBEs. So on Wednesday, we have tips for students who are parents on how SSSP can help you succeed and get your college degree. That is on Wednesday at 1 o'clock. Using the same TVE links that we've been using for all of our TVEs. Also on Friday at 1 o'clock is transferring from career and transfer services. And then also at 3 o'clock for Happy Math Hour, we're going to go over a review of exam 2, question and answer sessions. Make sure you come for that. Okay, guys? I hope you all have a wonderful day. Thank you, Mr. Azasi, for presenting today. And there are tutors standing by if anyone wants more information on the subjects covered today. Just let us know and we'll put you in a breakout group. Y'all have a wonderful day, and I hope to see y'all again next week.